Hello. The purpose of this video is to show the complete process of using technology and still communicating and thinking mathematically. A lot of videos dealing with usage of the calculator will focus on what you do with the calculator, what buttons you push, and how to get the answers. That's going to be sort of part of this video, although I won't tell you what buttons to push. I'm going to show you what the calculator displays are supposed to look like, but I'll also show you, other things that's supposed to go on behind the scenes, if you will, and how the written product should look. So, and start off with the thinking that you should do before you actually get to using a calculator at all. You should spend some time reading the problem, know what the variables are, understand what's going on. So we're talking about speed as x, which represents the independent variable. So I control the speed with mileage y. What is mileage? It's miles per gallon. So we talk about fuel efficiency. How far can you drive on 1 gallon of gas? So 30 miles per gallon means for every gallon of gas you can travel 30 miles. So it's set. Looking at the data, it appears as though if I drive slowly, I'm going to get a pretty bad gas mileage. If I drive a little faster, my gas mileage is going to improve. Now that's not true forever, because by the time I get to 75 miles per hour, I have, again, poor gas mileage. So it seems like there's going to be some optimum speed, some sweet spot where we can get the furthest distance on 1 gallon of gas. So that's, again, part of the thinking that's going on. So I'm guessing that mileage goes up and comes back down again, so we're probably going to see a downward-facing parabola. All of these things are things to anticipate. Now, reading the individual questions, we need to make a scatter plot, so I need to make sure I know how to do that. Use the regression feature, I have to make sure I know how to do that. Determine the speed for which miles per gallon is the greatest. We're talking about greatest mileage, which means we're looking for the maximum, so we're looking for the vertex. I'm probably going to use that negative b over 2a. So again, what I'm trying to model here is I thought about the variables, I thought about the function, I thought about everything that's going on here before I even got to the questions. And then I read the questions and sort of got through a mental map in my head as to what I'm going to do throughout the course of this process. So in terms of the technology, one of the things that I should do is make a scatter plot. So we start with hitting the button called Stat. We go to Edit Mode and we hit Enter. So we can put in L1 for the X variable and L2 for the Y variable data. Then we set up a viewing window. I use these parameters for my viewing window based on the data that I saw, and we make sure the stat plot is on and we can see the data. Now in practice I'm not going to actually plot all of these data, however if you have the time it's worthwhile showing how the data line up, but it's not a very accurate thing to do by hand. Anyway, so that's the scatter plot piece. I'm going to have to put that on paper, or at least the graph on paper, but I just wanted to work through the whole problem technologically first, and then we'll look at the write-up afterwards. So the next question was find the regression equation. So I went back to Stat and then tended over to Calculate, chose option 5, Quadratic Regression, and I stored the regression in Y1 so I didn't have to manually enter it. Gives me these a, b, and c values. So that means if I was asked what is the function equation, I should probably write down what the function equation is, which is here. We'll get to that in just a little bit. I'm just cheating a little bit here. This is one where you had to find the equation. Yeah, so there. That would be the equation of the quadratic function based on what the calculator gave me. So if the calculator gives this to me, I still need to write it down somewhere. So there it is. Next question was using the equation, determine the speed which miles per gallon is greatest. I'm looking for the vertex, which means I'm looking for the maximum of the parabola. So without showing you which steps, because this is from first quarter, I find the maximum, and the calculator says if you travel at 45.49 miles per hour, you'll get the highest possible efficiency of 30.44 miles for every gallon. So you get almost an extra half mile per gallon compared to the highest value on the table here. So anyway, all of that, I actually added an extra question just for fun. And hold on, bear with me. The question says, Grandpa reports an average of 26 miles per gallon for his car. What is his average driving speed? And there may be more than one answer. So write the equation to solve and show the solutions. In order to answer this question, I look at miles per gallon. That's mileage. So that's referring to my y values. So I set y equal to 26, specifically y2 equals 26, because that's 26 miles per gallon, and I want to find out what speed gives us that kind of gas mileage. And I see on the graph there are in fact two different speeds. Using the intersect feature on the calculator, I determined that when x is 22 approximately miles per hour, or when x is about 69 miles per hour, that we're going to see an average fuel economy about the same. So too fast or too slow, you'll get 26 miles per gallon. So just a really quick recap here. The point I wanted to get across is, first thing I do when I see a problem like this is I spend some time looking at the variables, and then trying to understand all the details and what's going on and that sort of thing. And the second thing I do is I plan out what methods I'm going to approach, and I actually do it. So I use the calculator to get the scatter plot, I use the calculator to get the equation, use the calculator to find the maximum, and use the calculator to find any other answers to the questions, like solving equations. Now comes the part where I have to write my responses. So the first thing I do is put together the scatter plot, or the graph. Again, you don't have to plot the data, but you do have to plot the graph that you saw from your calculator. So make sure to use specific details from the calculator's graph to get your parabola in place. Now, before I went any further, I just wanted to see how good or accurate my model is, so I decided to put in 30 miles per hour for x, which happens to be the speed, and then my table said 29 miles per gallon was going to be the outcome, the fuel efficiency. That's experimentally speaking, when the car went 30 miles an hour, this was approximate mileage. What my equation says is that y of 30 is 28.47. So my equation tells me 28.47. My actual data told me 29, and I can say this is about a half gallon off, which is not that bad. Half mile per gallon off. Part C, looking to maximize the miles per gallon. Before I had a calculator, I'd use negative b over 2a, substituting the v value from the coefficient and the a value from the coefficient on x squared. I got 45.5 miles per hour. I substitute that back into the equation, and eventually evaluate to find 28.47 miles per gallon. So it says if the car maintains a speed near 46 miles per hour, it will be the most efficient, yielding 28.47 miles per gallon. So I got the point on the graph. So in answers to questions B and C, I write down the equation and I test its validity. In part C, I write down the equation, I answer the question in context, and I show where the solution is on the graph to show that it truly is the highest point. For the last question about Gramps and his driving speed, I'm just going to write down the equation that I'm solving, because I want to make sure that the reader knows, or whoever's taking the test, whoever's reading my test, knows that I understand 26 miles per gallon is the y value. So I'm giving the y value of fuel economy, and I'm asking about speed, which is the x. So you write down the equation to prove that this is what I'm solving. But you don't have to do any more than that. Since we have the solutions from an intersection, we can just say that x is this or that. So if I ask you to use the quadratic formula, use the quadratic formula. If I do not specify how to solve, then solve using the most efficient way. That would be the technology. But at the bare minimum, if you're going to solve using technology, I'd like to see the equation that you're going to solve, the solutions that come out, and again, context. The only other thing I would do is I'd go back to my graph and I would show the solutions here and here, but I won't bore you with that right now. But anyway, I hope that's helpful. Don't forget the three things. You need to think first, then you need to actually use the calculator and know how to use the calculator to get your results. And finally, you should know how to write up your results in a way that includes all the details and is easy to read and follow. So, again, have a great day.